Lords joining me today or tonight. I tried to start this stream and then my software glitched, so I'm restarting this live video. Sorry to anybody who caught that introductory tale before, which is gone now. I am going to have to repeat my intro from that, which is that tonight, I wanted to cover some interesting and funny things that I've encountered in the land of wrong, incorrect proofs and claims that people think they have proven about things. And first of all, within this land, the reason I find this interesting is because we can learn mathematical errors to avoid. We can also learn human things to try and avoid that humans get overconfident in their beliefs in certain ways. And we can also get some humor out of it because sometimes it can be quite funny to look at the absurdist things that people are pretty sure they believe about the number pi. And if it was just somebody who believed this on their own, who got something wrong, I probably wouldn't feel comfortable pointing it out and sort of laughing at bits of it. However, these are people who are trying to convince the world of incorrect stuff, so I think it's okay if we poke a few holes in these incorrect things and look at some of the different reasons and ways someone might think incorrect things about the number pi. Sometimes this even affects history. For example, in this first case we're going to look at, there's something often called the Indiana Pi Bill. Now, actually, when you read about it, it has more to do with squaring the circle, which is an impossible geometric problem, meaning using a straight edge and compass, it's impossible to create a square with the same area as a given circle that you start with. And that is proven impossible. But in this bill, it is a legal thing in Indiana, in the United States, where I'm not going to go into it, but right now is an example of historically sometimes kind of bad, wacky stuff goes on in some governments and things like that. Not good stuff is going on politically here right now. However, here, there's a sillier bad political thing. Someone trying to present a mathematical bill to legally in the government system say that they have squared the circle. And the reason it's called the Indiana Pi Bill is because if you actually follow all of their logic, then it implies, if their proof was correct, based on the geometric things they describe, that pi is a different value. That's not the 3.14, etc. that we know. In fact, it seems like in this case with the model, we have, they just say stuff looks close to it. It's 32, they say, but it's really 31.4159, etc. And this is one of the types of failure we'll notice here is geometric things that are close to pi that someone drew and measured, which has a lot of places you could have human error. You know, the measuring tool, the human eye, the ability to draw or hold something with your hands properly. So many ways there could be human error involved when you try and trust a measurement for something like that, especially when you realize that even 3.14 is absurdly accurate unless you have a massive circle. And so 3.14 for a circle like this big would be within less than a millimeter off. And so, I mean, this isn't a perfect circle, but if it was a perfect circle of a reasonable size, you don't need that many digits to get a good physical world approximation of pi. All the cool things about pi are related to its mathematics, not that we need to know more than 10 or 20 digits. I remember NASA only uses like 40 digits or something to do space travel related things, at least last I read. And so it's really hard if you want to show pi is slightly off 3.14. You would need to be measuring on something massive, super precise, and you'd want multiple sets of eyes double checking it. And if it just doesn't line up with the math, of course we're not going to trust one person's measurement. Sometimes people will say here, you have to try the measurement yourself. But then they don't believe it if someone tells them I did try it and it didn't come out to the same result as you. So, And this is just one example of a historical one that, let's see if we can find some of the actual text of it real quick. Original text. This is a typed out version of it. So they wanted this to go through a government set of court to become like legal. Be it enacted by the General Assembly of the state of Indiana, it is found that a circular area is to the square on a line. Then they describe in words a type of geometric configuration that they claim is exactly the squaring the circle ratio that is impossible to do. And I need to restudy this, but I believe the fact that pi is transcendental relates to why you cannot square the circle, because a transcendental area tried to be compared then into an integer doesn't work very well. And here we can see this whole thing that luckily it did not fully get passed as a bill. And there, if you read through this, you find that different claims within it make different wrong things for pi. So it's almost like pi is not equal to pi if you follow the whole thing. Now, this is from a while ago. So you might think, okay, maybe mathematicians stopped doing that. No, there's a lot of false proofs out there. And like I mentioned, pi is a recurring thread among them. So let's move to just one of many other websites that I have pulled up here. I don't even know how many of these I'm going to get through, but there is a variety of sources I have saved here. This first one is called Measuring Pi Squaring. Some people call this phi, some people call it phi. Now, normally I do go with the phi pronunciation because that's closer to original Greek. But if we're going with original Greek, pi is closer to p. So, like, we're not calling pi p, so calling this phi or phi, I'm cool with either, because we don't want to be too strict about the original Greek pronunciations, or we have to start pronouncing that closer to p. Anyway, this is Measuring Pi, squaringphi.com, a website with many sections. Now, this person believes that pi is a decent amount off from what it actually is. You know how I was saying 3.14 gets you a good amount of accuracy? But the next digit is a 1, not a 4. So if you had a pretty big circle with good measuring supplies, you could tell this was not pi, that this is too big. And so this person did a poor job of measuring, which is part of it. Now, they say it's exactly... this is an approximation, but they say it's exactly 4 divided by the square root of phi. So that's another recurring thread. Some people will say, oh, pi is secretly some power or root or some expression algebraically related to some other classic variable. Pi is really this thing related to, oh yeah, and I guess I should note, for anyone who doesn't know, this is the golden ratio, is phi. And so it's a nice thought that pi secretly has a link to the golden ratio in this way. But if it was this simple of a link, I feel like mathematicians would have noticed that even just here in the thousandths place, it's 3 thousandths off in that place. And so that's significant error here that has been. We have measured circles big enough that there have been physical circles calculated with better accuracy than this. And, oh yeah, that is 3 thousandths. They claim pi is too short pi. And that is, you might think, okay, that's a good amount of arguing this person did. But remember, they have a whole website. You have to pay to have the website domain. And I don't even see ads here, so they probably are paying for hosting too. So this person is currently paying every year to keep this website up. So you know it's not just about this section. You know that they got a lot of sections. Pi measurement shows us some of the ways they measured it. With these tools that are obviously incorrect. But I don't even know if it's the tool being wrong, the human measurement being wrong with the eye, the human hand doing something wrong, because there's so many ways that could go wrong. It's the type of thing, if you checked that, you double check with someone else, And obviously this person is in the category of people who, whenever someone else tells them, "Nah, sorry, you're wrong," they're like, "No, nobody believes me. Nobody understands the truth but me." So if you think you've proven something really wacky about math, cool, but be open to criticism. The best mathematicians want criticism so they can refine their work to its perfect form. And they want others to understand it. If nobody on earth understands your thing, or even worse in this case, if they understand what the error is, but you don't believe them on what the errors are, then you get some issues. And here we have some geometric proofs. So, geometric proofs of pi. There's this one. And here we can see, let's see. Here they have drawn circles, and these ones don't even line up with those lines, but some line up with the lines. And right here, when they're drawing it, some of these steps, they're just claiming right here, yep, that bit is exactly the golden ratio, or here, like half of the square root of the golden ratio. Here it looks like they've drawn a golden triangle on top of a bunch of circles offset from it. But what happened to this sector of the thing? It does, like, the amount that the circles go through is this arbitrary rectangle right there. And this might not even be a golden rectangle. It looks too long. Yeah, that's too long, I think, to be a golden rectangle. Oh no, this whole thing is the golden rectangle. So what's up with only this sector of it, this rectangle out of it, covered by the circles? So they've drawn a picture that has a golden rectangle and circles in it, and then they just say, oh look, the line, this line does all this crazy stuff. But mathematically, B is just hanging out here in the space. How do we know how far off B is? And, like, what's up with this gap? Now, as we can note, of course, the geometric proof must result in the wrong answer, and even if they drew it big enough, they might realize, due to them thinking it's 3.144 something. But they also have other proofs. So, first, they say, let's get rid of the erroneous notion that pi must be transcendental. It has been proven, I'm sorry to this person, but pi is transcendental, but their equation would be non-transcendental. It would have an algebraic form involving types of root and stuff. So, here, MathBrand. I don't necessarily want to do another video in a video, but I also did want to just show on this website real quick 5 more universal constants. So here we have pi 1, pi 2, all the way up through pi 6. These are all different ratios. Pi 1 is 3.144. None of the pi's are the one that everyone else agrees is pi. None of them. None of them are tau either, the other, like, contender to be what would be considered a pi-like thing. And we have let me see some notes in the comments real quick. Someone notes you can construct cube roots if you fold the paper. That is true. Paper folding adds things you can construct that you couldn't otherwise do with a compass and straight edge. That may be a topic of a video of mine someday, at least with the relationship between Fermat numbers and constructible polygons. Now, we have notes about the geometric proof looks correct, but if you do it digitally, you can see how it's clearly wrong. And we have some circular reasoning in one of these, which is going to be another common thread. We have somebody has something they want to prove, and they use that in the proof of where they're trying to get. That's going to cause a lot of problems. Now, this is just one, so although there's a lot of other fun things on here, I'm sure, let's move onward. This is another one that sort of, this one goes on and on for a long time about other stuff and about how in the numerology type claims of, like, the golden spiral's everywhere. Is the golden spiral in this? Out of all of the things, maybe, but I don't think so. But maybe, actually. This is the type of thing it could be in. but it's not in as many things in nature as some people think. You can have a logarithmic spiral too, and other sorts of spiral. It's not always a golden spiral in nature. I'm sorry, but you can at least have solace in the fact that the golden ratio, although it may be overrated in how much people see it in nature, it's underrated in mathematics. It has so many cool traits. So look up my episode about the golden ratio if you ever want, and my episode about the Fibonacci sequence, which are two different ones. But here, the reason I brought up this one again real quick is it is similar. They have a different equation, but one related to the golden ratio and pi being together. And they say that pi is 6/5 of phi squared. And they say these are the seeds of God's grand design or his fingerprint. Be careful if you mix your religion with your proofs. Maybe first do the proof, then add all on the side. Put all of the religious implications. When you put the religious implications in the proof, and then you start trying to creep them into being part of what's proving the thing, often it results in an incomplete proof. Now, they have this actual equation. This is why stuff like this is just like spreading such wrong knowledge. It sounds confident if you didn't know, but they're talking about a real equation now, and they're just mixing it up with wrong things about the real equation and that one. And how close is this one? 6/5 of that? Well, someone look that up on a calculator, see how close it is. I already showed in a recent episode that we can trick a calculator into thinking something is equal to pi when it's not, when it's close enough. But calculators aren't people. This is where people are supposed to be better than calculators. They can double check other sources. They can look at their work in multiple ways. They can try and see if others agree with the work, and so on. Now, here's where it starts getting kind of wild in this one. They start talking about how it's all over the pyramids, and I saw that in a few of these. They love being like, okay, so pi is the spiritual thing, but everyone has it wrong, but the true version of it explains something about the shape of Egyptian pyramids from history. Very specific sounding, but that has recurred in more than one of these. And here they're going into some numerology about 369. Again, I love three even numbers more than anyone, but a lot of the cool things that 369 do, if we're not then going 12, 15, 18, if you're saying just 369, that's dependent on base 10. Their cool cyclical patterns relate to 9 being one less than the base we count in. And so it should B minus 1, where B is the base you count in, should be what gets the credit, not 9. And the factors of B minus 1, similar to 3, getting some credit as well. So careful with the numerology that gets mixed into some of these, which is people thinking that this must be true because it feels true because of some historical connection, or because some connection in their personal life, or as we'll see with some, a connection with alphabets. There are some where people think that assigning the modern English alphabet, which was evolving as recently as the 1800s, explains pi, which has been around a lot longer than that. Pi just is around. It doesn't even have, how long has it been around? Pi just is part of it. It's not even around. It's if you're around, then you're related to pi. But, it is around. But here they go into things about the Fibonacci sequence repeating a pattern. This is something I have made an episode about. My Fibonacci episode goes into, and those are on my main combo class channel, where my best episodes go. That one is about how in any mod, which is sort of like the last digit of a given numeral base, the Fibonacci sequence cycles, and why that makes sense, and what cycles it has in base 10, in other bases, and here they just go with one of them. They go with the base 12 one and say the base 12 one explains the whole universe because in base 12 it cycles. Did they look at other bases and see that it has a different cycle, but some cycle in every base? I don't think so. Same with, I don't think they checked if other bases have this property about how nines do cool digit things, because that's the B-1 thing I was talking about. And here we get some more of the mixing in, I guess we could say, philosophy with the math. And because, like, save it for the end of the proof to say this tells us something about the universe. It's getting confusing when in the middle of the proof, this is like one of the reasons you're now giving why this all happened, or is, because, it's hard to tell with these proofs what is a logical deduction and what's like an anecdote they're sharing. So here we get some more, and this one has a lot, but I mostly wanted to show it because it relates to thinking pi is related to the golden ratio. Now, let me find the next one we're going to go to. Let me get this well-sized. So, here, this one says pi is a rational finite number. This one is stevepatterson.com. And pi being rational is the next step that's very common. Rational would mean, it doesn't necessarily mean that it ends the decimals. Some people think, oh, there's an end to the digits. Other people think that, oh, it goes into some repeating pattern that repeats forever. Either of those could be rational, but we know it does neither. But that's one of the classic things that people fall into this like list of misconceptions. With pi, some things we have to get clear. Pi is known and proven to be irrational, to have an infinite non-repeating decimal in any type of base, in any integer base. You could go in base pi, but then integers would be pretty hard to make. And here we have, on the other side, I also want to mention, we don't know for sure, not 100% proven, that pi is what's called a normal number. Meaning we don't know it contains every string of digits ever. A lot of people assume we know pi has every text. We know pi has every small text because you could check little blocks of digits, but we haven't proven pi has every single possible digit string like the traits of what's called a normal number or an absolutely normal number. So that's a common misconception, but mild enough I didn't include that in these ones. But it's one of the most common misconceptions. People saying you can definitely find any possible string of digits in pi. Probably yes. Not proven. So let's look through this real quick. And I love what people always think when they made these proofs that like the math world is out to get them. They always phrase it like, I am this outcast fighting against the demonic entity. And the demonic entity is every other mathematician's belief in math. And every math textbook that's ever been published. That's my enemy. So there's a heresy comes in different levels for the and da-da-da-da. And here they're trying to say something about how obviously someone called their thing a crank before, which is a term for people who do this type of thing. And so they throw it in the beginning of their paper. I don't know if this is a proof. This might just be an article, but they throw it right in the beginning here of saying disagreement with mathematical orthodoxy is synonymous. And they're like mocking that they don't believe this. They're saying that this translates to somebody called me a crank, but that's just because they didn't understand. And you're not allowed to doubt ideas without being condemned. And it's like, no, you can doubt ideas. People are happy to hear your paper about how you magically think pi is rational. But if you just say all the criticism is wrong, then people will condemn you if that means that they say you're wrong. So, are you really condemned? Your article is still up. No one took down your article. You were allowed to post this. People just might disagree with it. And here they say on shapes. This is a circle. This is a line, and these are points. Then those are okay statements. I mean, it's like, different mathematical things treat things differently. There are other mathematical things where this picture would not represent a circle. could represent the unnaught or something. So it's not true right away that every mathematician agrees this has to stand for circle. Symbols mean different things in different contexts. But so far, not that bad. Okay, there's a way of looking at those until they say, if you believe these are indeed circles, lines, and points, then even already here, that's sort of crazy because it's like, no, well, if you're going to use this to prove something, then who says I believe these are points? Maybe I'll say they mean something else. But if you believe that they are, then you too believe that pi is finite. It's like, whoa, big logical jump there. You see, mathematicians don't believe these qualify as lines or points. In their minds, lines and points can't be seen. This is being so pedantic. It's like, because you can't actually draw a line, this isn't a line, so everything's wrong, including how we think of circles, and that means pi is rational. And so here we get questions. Great questions, dude. Try and answer them. You know, there are great answers for these, and there are different fields of math where you would define these differently. But there are no fields of math where pi is considered, useful fields of math where pi is considered rational, because rational has a very clear definition. It means you can be made of a ratio of two integers. And so you can change that definition, but then you're arguing something really random for the people who are like, seems like they're arguing it's not rational, but really they're saying, no, but rational is defined wrong. So it's like, okay, well, the thing that most of us call rational, do you think pi is that at least? Because what you really mean maybe is that the term rational is a bad name. But like, just because I think imaginary numbers are a bad name, I don't just start using some other confusing term without ever explaining why I'm jumping to it. Actually, that kind of sounds like something I would do. But no, anyway, here we have, and I'm not immune to mistakes, but I'm open to criticism. And that's these people's downfall, is not being immune to criticism. There are other people I found who their websites I could only get through an archive. And while I read some funny bits, if the website was archived and taken down, I don't think I'll show it today, because the people who still have a website post up, those people are still spreading bad information into the world. So I think, this can, apart from thinking it's funny, we can also learn some things about things to watch out for if you hear somebody's supposed mathematical findings. There are some recurring traits that you could say a crank would do, but this guy would get mad if you say that. So anyway, here they're saying that, okay, the objects we experience are composed of pixels. So their whole argument here is basically boils down to, it's impossible to draw pi in the real world perfectly, therefore it doesn't exist. And it's like, well, okay, but let's throw away the number 2, because how are you going to perfectly draw the number 2 in the real world? So let's just get rid of all the numbers. Numbers mean nothing. Okay, now we need to reinvent a term to mean how many of a thing I have in my hands. We should just call them numbers. So you can throw away titles, but then you find, okay, why don't you, if you want a different definition for that, come up with a new word for that the thing you're talking about. But to say the other term is wrong is just a weird, not even a mathematical disagreement. You're just going after their language being wrong and acting as if that proves something mathematically. And the language isn't even wrong, it's just something that you don't like the taste of. So anyway, they're saying you can't actually make pi in the real universe. Now, I have an argument against this type of point in general that I wanted to note. At first, I used to think that, okay, pi is definitely a mathematical concept, but whether it exists in the real world is sort of ambiguous. We don't know scientifically. However, now I sort of think of it as pi is the limit of many processes involved in the real world. And so pi does exist in the real world as a limit. And limits are not the same type of observable, but not everything is. And so pi as a limit in the real world is a useful tool to think about. But also, if you're disproving something about pi, and it's only about the physical world, you have to split it. You have to rename what you want to call your I think pi is actually different in the real world circle constant from the other one that mathematicians don't claim that pi is perfectly replicatable in the real world. It's a mathematical concept, and believe it or not, humans have imaginations that let mathematics make us think things that you cannot see with your bare eyes. So here's one more of them. And now moving on from here, we're getting onward to sort of more like four, and I'll look at the comments in a bit, so feel free to leave comments, but right now I'm just knee deep in this. And so now we're getting sort of more to forum posts. And while they're not as big scale of how many people they might be affecting, they're still interesting examples of certain worldviews. And one of the forum posts that I managed to find a very wrong pi argument on, big surprise on what it was. The huge surprise is that it's the Flat Earth Society's website. I know you're all absolutely shocked that a flat earther would think something like this, but you know, flat earthers don't even all agree on whether the sun exists. I've heard of some that think that all of them are still planets, but something's fake going on, or they're like, I mean, apart from the Earth, the other ones are still balls, or that only some of them are. In any case, when you're thinking about flat Earth, you're thinking about how circles are fake and a big conspiracy. So if you thought the Earth was flat, I can imagine believing that pi was also some government conspiracy. And I don't think I even need to argue, if anyone for some reason needs the argument about why flat Earth isn't true, or one of the many arguments that could be made, let me know. For now, I'll save that for another day, because I think it's pretty obvious to all of us at this point. The Earth is something closer to what's called like an oblate spheroid, which is a, spherical, somewhere between a sphere and an egg. It's very close to a sphere, but it's a little bulgy in one way. And here they say, by experiment, it is on the Flat Earth Society website forum, by experiment, existing pi is a little bit smaller, not to mention, I think that means they're saying that it does equal this, 3.125. They're presenting it kind of like a dramatic twist in the story, like, not to mention this number. And I'm guessing they're saying it's actually pi. And that's sort of the only place this is their equation. And, this is physical measurements they did. Their measurements are really wrong if they measured pi is 3 1/8. That's what this is. So, we have some other, I don't think I need to see these arguments from the other people against this, but I'll just let you know that not all of the people responding were correct as well. Now, I do have a couple more wacky ones. Let me take a quick peek at our comments. And we have a lot of cool thoughts. Thank you all for sharing that and joining me. And we have a note that if circles were hexagons, this is from Benzene, that if circles were hexagons, pi would be 3. I've had those thoughts before about what is pi for other polygons. The problem is for circles, it works for circumference, but also for area. And so you can't have a singular pi that works in the same way for other shapes, circumference and area, unless all the equations change every time. However, it is still a nice thought that just in terms of circumference, pi would be like 3 to a hexagon. And let's see, leave a comment if you have any thoughts about where that pattern continues. And here we have some other ones I'm going to pull open. The next few involve some from a particular subreddit that this is somewhere that people get sent when they're putting crank-like math theories onto other places on Reddit. On the other math subreddits, if someone's posting crazy sounding stuff and really wants people to listen to them, they tell them, posted on the subreddit called Number Theory. And that's actually the whole point of that subreddit, at least at the moment. And I'm kind of sad that was the name they took, because I love number theory is like one of my favorite parts of mathematics. So I kind of wish they had done a different one for their joke one. But I gotta say, I check this thing like once a week, and there's not even always a new post because they're more spread out, but they're so good. They're so interesting and funny to me that I check this thing like every week or two to see which new ones are here. And this is one that came up relatively recently, 10 months ago. And this is just one example of the crazy rabbit holes people who do a little less work into it than some of the other ones. Okay, actually, before we do the smaller ones, I have to note that there are people who, some of these were the ones that it's now archived, so I don't know to what degree they still believe this, so I'm not going to put them in the spotlight here in case they learned better or something. There was not a non-archived current version of their website, but some people, 2 different ones I found, wrote a whole book, each of them more than 100-page book, about why they think the value of pi is different than the 3.1415, etc. So if you're going to write a whole... Actually, that's one of the less harmful things, maybe, because that's a lot of hours they could have been making these forum posts that they were just on their computer typing their book. So maybe that's better. Give it to the world all in one blast. Here I've seen some people who sort of incessantly try and repost these on different places trying to get someone to agree. And when the other people poke holes in the logic, the people here are always like, no, you don't understand my theory. And they act like it's this big conspiracy against them. So here is just a really weird misconception. I've been looking into pi and the roots of 1. Okay, so far, what does that mean? We could talk about the roots of unity. Those are like the square roots of 1 are -1 and 1. The cube roots of unity are 1 and 2 complex numbers. The fourth roots of 1 are 1, -1, I, and -I. See my episode I made a while ago about the roots of unity, or that episode's called The Clock Hidden in the Number 1, if you want to learn about those. But for some reason, this person says the roots of 1 being 11 over x. And I saw a comment somewhere on one of the replies. I don't know if it was this subreddit or somewhere else they posted this, but someone said they think they figured it out. They think that the root of something, the xth root of something, at least to get like a certain root, can often be expressed. If I want to talk about like the principal square root of 2, I can call that 2 to the power of 1/2. 1 to the power of 1/3 can be a way to write some cube roots often. And so maybe they saw 1 to the power of 1 over x, and they mushed it together to think 11 over x. But anyway, they end up doing this thing that, as this comment points out, this just in, dividing a number by 11 pi, then multiplying the result by pi, then multiplying your number by 11 yields your original number. So, yeah, that ends up being what's going on here. Sometimes really, really simple math mistakes are that, like the game you'd give your friend as a kid. Take a number, double it, -2, do this. Now I know what your number is. When really you at some point subtracted the original number and you came up with which other constants were in there. So, cool looking for that to this person, but maybe be careful on if you see something to the power of 1 over x. It doesn't mean just add those to the end of the last digits of the thing. So now we have one here that says the circumference of a circle done better. Intriguing. How could we do the circumference better? They say we know this is a really arbitrary amount for them to agree on. Maybe they measured to get this, but it's like, why can't we say we know it's between 3.14 and 3.15? Because we know that too. But they agree on the between 3 and 3.3 in length. and that 3 diameters stretch around the diameter of the circle. I think they mean circumference here and mean a little more than 3. We can simulate this, and they're describing drawing something, but nowhere in the math here would this come out to 3.14. And they end it with pi equals 3.14 and is not irrational. And so they're acting like it's a math proof, like describing it geometrically, but they must have just measured something. And they sort of hide the fact that they got their answer from measurement, because why would you have gotten that from these stats? So if you're doing a measurement, let people know that it's not math, that it's, what do you call it? Engineering or whatever that you're doing. Here we got another one. Here we have somebody who, I wanted to show this as an example of people who think the modern English alphabet has something encoding some secret that pi is trying to tell us from the universe. And it's like, dude, do you know that the letter J wasn't even in the English alphabet until the 17 to 1800s? And so it's evolved a lot. Why would some ancient forever number like pi be encoding something about the language that humans happen to use in part of the earth at a particular time in history? And some of these people actually think there's a reason. Like, this is the destiny. The code in pi knew it would lead to this. But here, this person put so much time making this grid of things. It's all good. Have fun with this. But they draw such arbitrary looking conclusions of small patterns. Look, I found a few spots. There's 577. I couldn't find more, so I had to highlight a 5, 7, and a 7 on their own, too. Those are those are linked if you wrap around. But this is the law of small numbers. You're going to find in sets, when you're looking for a small thing, it's going to show up all over. And so you could do this randomly with a different number. Do this with the repeating decimal for square root of 2 divided by square root of 3. And you'll find something like that, not necessarily with 577, but with some string or another. And this person has some crazy deductions about what they think this all means. These secret codes that are in pi. It's not even just the modern English alphabet. It's the way that, how do you pronounce that? ASCII or ASC2? I don't know how to pronounce that, but the modern way that a lot of type is formatted, like the name or the number that's officially given to certain symbols. Like, how do we, show what the dollar sign is or something? That is some symbol here. And so, based on that code, that specific way of putting information, that is what pi is trying to tell us. A mix of English and this particular way of formatting text. Modern English. And what does all of that jumping around get them? A few mild coincidences. I don't even see what is that weird about the stuff that emerges, even with all these assumptions. So careful when you're looking for stuff like this. That person actually had several posts, I found. I don't know if I need to show all of that person's posts that I have here, because there are a few, but the other ones are sort of similar. There are other ones, though, here. And this one, although I was trying to just isolate pi, this might be a golden ratio one we're getting in the mix. It could be a whole nother video about people doing this for the Collatz conjecture, because that's another really misunderstood one, or a few other things in math people just don't get. But pi is mysterious enough and simple enough that it hits a lot of people just wrong. Let's see. Golden ratio, new findings. Well, let me pull open a few in advance real quick, and then be ready for a couple links right here. And Oh, here's something I forgot to, or I'll see if I get around to that bit later. It's semi-related. Anyway, for this fully related still bit, this one's a different take on it. It's not about why pi is wrong, but it's close enough I wanted to include it. It's about 360 degrees being the way we divide up the thing. And this one isn't at its heart in some ways as bad or whatever as some of the other ones, because they are just arguing that they think the convention's wrong. They're not mistaken like some people into thinking 360 degrees is a fundamental thing. That was just chosen because it's a highly divisible number with a decent amount of digits. And so it has a good amount of factors. And so this person doesn't have those major misconceptions, but they just have a really funny opinion on what makes numbers important. So they take, this is all base dependent too. They take digit sums, and they don't like the fact that when you take 360 or a lot of factors of 360, like 45 or stuff, a lot of the factors of this or itself add up the digits to 9. They don't like that they're all equal. They think that it would be better if when you go to half the number, it has half the digit sum, which I can kind of, maybe that would be neat in its own way if this is the trait we're comparing. But that, and then so they show like 420 would be a better one. But their logic ends up giving them that 370 is the right amount of degrees, a number that's way less divisible than 360. Talking about fractions of that show up in common triangles would be so, imagine like the 45, 45, 90 angle triangle. That would be way harder to describe, but they think it's much better because when you take the digit sum of it is twice the in base 10, twice the digit sum of the other, of half of itself. Now, here's a little golden ratio one that did make its way into the mix because there's a pi right up there. And this looks wrong, but I think they're just rounding, in which case it's technically right to put the 2 there if you're rounding. So here they have some interesting equations, and they claim that twice the golden ratio is pi plus that bit, which it's close to based on their math, but wait a minute. When did the about equal turn to an equal? We got a little problem here when the about equal just sneakily just flattens out. Just, don't mind me, I just flattened out a little bit. Nothing different here. So how are you going to go to this thing when you're saying, okay, no, finally, they reintroduced the about equal. Here is just a few wrongly written ones, but the about equal comes back. Good. But here they say that this is a really important one called the Golden Trilogy equation. And what I like here is on all 3 of these points, they go, coincidence? At the end of it. Coincidence? And yeah, it's interesting that that is close to true. I also don't know why you would make I squared written like that instead of just calling this -1, putting plus I squared. But yeah, it's neat if that is close-ish to true, but it's not nearly close enough. Let's see which other ones I have here. Oh no, I have to show the top comment here made me laugh. This is, I didn't even notice this at first, but look at this. This is actually why I included this. I forgot. They have a merchandise link, and the top comment made me laugh. It's like, plugging merch on an infographic about a very loose approximation to only 3 significant digits is extremely weird to me, not gonna lie. And I did check out the merch. I'm not going to show it here. I think they fixed what this person's talking about, but apparently at the time, the merch was a triangle that said golden rectangle, but are labeled golden triangle in one of them. So I don't know. I would buy that if it still was the wrong one. That would be funny enough to buy, maybe. Um, and the next person said they can't tell if it's ironic or not. Now, I've checked when people post stuff like this, if they post this stuff elsewhere, if they believe this stuff. And almost all the time, the people do definitely actually believe all this stuff. It's not ironic, but it seems ironic at times from how extreme people can go down different rabbit holes. This one's not as crazy. It's just funny that they're plugging merch for this. But the other ones have, as we've seen, a number of different misconceptions. Now, let's see what other ones I had here. Well, actually, here's a better one. This is something that some of you may have seen if you watched the channel 3 Blue 1 Brown covered this in a video. But this is a better version of a wrong pie proof. It's like supposed to trick people in a clever way, and it knows it's not really true. It's just seeing like, where's the error? So you draw a circle, you put a square around it, and we have the perimeter of the square being 4 if the diameter was 1 there. And then we remove the 4 corners by like tucking them in, and the perimeter stays the same. Because imagine it was out there and we like tuck it in, the perimeter is the same. We do it again, the perimeter is the same and the same. And it is actually technically true. The perimeter of this one has not changed. But we cannot repeat this to infinity in the way you might expect to get a circle. And one way of phrasing that is how one of those things is looking at the limit, what length is it? And another is looking, what is the limit of the length progression? And those end up being a bit different. So this is a more clever type of one that if that one tricked you, I would blame you a bit less. But the person here, that was on sharemathideas.wordpress.com, they are not trying to spread it to actually trick people, I am pretty sure. Let me see some other notes we have here. And some comments note that they think that there could be some genuine mental illness in some of those cases. I suppose that is true. So to the people who, if this is a sign of they're struggling for mental health reasons, I'm sorry if it sounded like I was making fun of any of these people. To be clear, I'm okay with people roasting me. This is how I talk to my friends. So in my eyes, I'm sort of treating these people as if they were my friend. Sort of, it's good to be able to be laughed at. Especially, if you want to show the world different ideas and things. Or like, to me, I want to show the world videos. It's a good thing I'm okay with being laughed at. Make sure, that was part of why I said at the beginning, do not actually look up these people or try and go deeper down any of these rabbit holes, because there's no reason to bother the person or obsess about them or whatever. But given that they still have some of these things, some of the Reddit posts, I suppose, could be closer to people who are just struggling in different ways. Some of the other ones that are really, really well formatted websites that are, they're currently paying to host the domain and stuff. I'm not sure in all those cases to what degree it relates to that. But I do think that I understand if anyone thinks it's smarter to tread lightly on making fun of other people like that. I like to roast people in a casual way, but I would never try and spread hate about these people or say that they're bad people or something. I think that some of these thoughts are really silly, and they may have a mildly bad impact by teaching people the wrong things, because I've seen a lot of people link things like this and be genuinely tricked by them. And so, yeah, I do tread lightly in general. This is one of the only circumstances I give myself the free will to roast another thing online in a similar way that I would roast one of my friends. one of the only cases is when there's proofs that are radically bad. But hopefully everyone who's doing these is coming from it from an okay mental place for whatever reason or another. I do certainly think that that is an important thing to think about. I have my own mental health issues, and it's something that does still need more awareness, even though there's been more awareness since the past. It's something that people misunderstand a lot. So, what are some things overall that we noted we want to be careful from these ones that we looked through? Well, you want to be careful conflating physical measurements or physical relations to things like history or to things like the alphabet you use with the math. You want to be careful with when those get blurred together. Some other things that we found is it would be really nice sometimes if pi had this big twist, but what the really nice thing that your logic feels really good for could be true if it's an untrodden field that not many people have studied or anything. However, some of these things, it's sort of just, it's being so distrustful to humanity that when these people present the ideas, the ones I highlighted, the ones I've showed today, there were some I didn't show because maybe the person was just mistaken about something or whatever. But the ones I showed, the people were very argumentative in some of the other stuff in general about wanting to make these points or trying to basically shut down any possible criticism of it. And I find that sort of so distrustful to the rest of mathematics and humanity that that's one of the biggest problems here. It's not that they're bad at math or whatever. It's that they're convinced that all of mathematics and society is that everyone else is either not trying as hard as they are or is dumber than them or something. Because how else would you get to the conclusion if everyone else thinks your conclusion doesn't make sense for reasons they line up? So be careful for those and other reasons we've seen if you are putting together different sorts of proofs. We have some notes about sometimes phi does appear for reasons not related to the ratio of the rectangle. If you mean related to pi, there are some really interesting things you can do with infinite products and limits and things like that. A lot of cool connections between different mathematical constants, but we know for a fact that pi is not something like fraction times a power of the golden ratio, or at least to to a whole number power. And let's see. We have a note about some people trying to develop a big ego over it. It is true also that some people kind of like it was sort of funny, the one selling the merch, but other people are like, okay, this is the equation named after me that I discovered. Are you going to start talking about this to all your friends, the equation named after me? And so it is a bit egotistical to think that your whatever 100 hours you spent on the problem, or maybe 1,000 hours if you spent a long time, outweighs the thousands of hours that anyone else has spent. And we have another note that some people have personality disorders of no intention of treating them. I hope that is the case in the people who this stream ended up being a little bit of laughing at different things as an example, but we need to use people for examples of different things. And I can be the example when I've made mistakes. So I'm not a perfect person. I have mental health issues too, and I make mistakes. And if somebody ever finds one of my mistakes or thinks that I did something wrong, especially if I'm presenting it in a confident way, then I hope they let me know so I can get the criticism to edit it in the future way I refer to that or whatever. So I suppose the main thing we could learn from a lot of this is to be open to criticism and just open to others' beliefs and the fact that others have spent a lot of time on these topics as well. And maybe it's different if you come up with a new function that maybe no one's ever explored before. But we know that pi is something people have dedicated a lot of hours to throughout history. And we have a comment about how one of the issues is when they discover something, they think it invalidates everything done about science. And yeah, that is one of the problems with these types of belief that don't fit into other things very well. A lot of mathematics is interlinked with the fact that pi is irrational and transcendental. And so you get this whole domino effect of things that would have to be wrong about math for your thing to be correct. Now, also, to be extra clear about if any people, the type of people doing these, I don't think they should quit doing math. I think they should tone down the confidence. I think they should keep trying this type of stuff. Obviously, these people are more like, what would you say? They have a better imagination than the average person. They're coming up with cool, possible theoretical techniques, theoretical ways of looking at stuff. So in some ways, if they weren't so overconfident, then these people could be praised in a weird way for just approaching these problems from a very different way, which, it's always going to be important to have people who try and innovate in a different direction. So in some ways, these people are doing great things by pondering all these things. The problem is when the pondering turns into arguing with others about how they don't believe you that you've proven it. And there's a lot of other comments I'm not going to be able to fully go through right now, but hopefully people have enjoyed that portion of the stream, which is most of the stream we'll be doing today. I'm probably going to wrap it up with a few other random thoughts I wanted to share related to the Combo Classroom and related to this month and stuff. So if anyone is just here for the weird proofs, I guess see you later, and make sure you're tuned in to my Combo Class channel where my best episodes go. There will be a new episode out there before long, in somewhere less than a week from now. And to anyone who's curious about a few other things, I wanted to note, we're entering the springtime, and me and some of my family members planted some plants in a yard area we share with some other houses and stuff, but some edible things that I hope are going to do well. So far, having an issue with something like snails is eating them, and I couldn't see them in the day, so maybe I got to look now if there's any night snails or whatever. And I mentioned that to someone. I was like, yeah, it's probably night snails. And they're like, night snails? As if that was like a thing. They're like, what's night snails? And I'm like, no, I mean like with a space, like a night snail, a snail that comes out at night, not like a species called night snails. But maybe those are a thing. But what I wanted to note is that I don't have any of these growing, unfortunately. This I had to get from a store. But I will have, if any of these end up fully working and not getting eaten by bugs, there'll be broccoli, there will be some bok choy, there will be some strawberries, there will be some peas, and some grapes, and some more stuff. So we'll see which of these work out. And also, above the classroom, in the daytime, you'll be able to see next time, if I angle it that way, that these trees that I believe are rarely fruiting plum trees that occasionally give a couple fruits of plums that I've eaten, but they don't make many, are doing their beautiful little blossoms. They have cool little plum blossoms right now. Now, I've been busy the past week, so I still have some things filmed that I need to get to editing and putting out on this channel as bonus content. Those will be coming, more stuff on this channel at a faster pace soon, but I have gotten some really cool stuff filmed recently, and I'm extra excited for the next few main episodes on my Combo Class channel. And there's other thoughts that I could share, but I think that's a good amount for the stream because I wanted to keep it mostly on one topic. So special thanks to the people who help fund all this stuff. That is my Patreon supporters and YouTube members. If any of you have any extra budget, consider helping out one of those ways. You also get some bonus videos. Plus, it just really helps me keep the show going and improving, making each grade better than the last. And a lot of fun stuff will be coming soon. The train is getting loud, and I will use the train sounds as my outro for now. I love you all so much. Hope you enjoyed. And remember, don't ever bother other people, if we're making fun of someone's bad proofs or whatever, never bother that person. Don't go dig through their stuff or whatever. It's a one-time look through these people's current beliefs they seem to be projecting to the world, because it's what currently they have showing to the internet. That it's a one-time look to find some misconceptions and some human strange ways that humans can overbelieve in certain things. But these people do not have any inherent problems or whatever. In fact, they're pretty creative with the way they think about it. So if I ever show other people's websites or whatever, don't bother them or anything like that. But anyway, thank you all so much for watching. I love you, and I will catch you again soon.